HVAC temperature rise formula and safe airflow CFM checks let you verify system performance quickly and avoid dangerous misreads when the electrical compartment is open. Measure temperature rise by taking supply and return air temperatures with the system at steady state, then calculate airflow cubic feet per minute using the formula CFM equals 60 times the heat input in British thermal units per hour divided by 1 degree in specific heat of air, times the density factor, times the temperature rise. In practice, use CFM equals heat input in British thermal units per hour divided by 1.08 times temperature rise in degrees Fahrenheit for single return systems. Start by confirming correct gas input or electric heat wattage at the unit nameplate, and convert to British thermal units per hour if needed. For gas, multiply natural gas input by 80% only after confirming furnace efficiency from combustion analysis. When measuring temperatures, place high-quality thermistors or thermocouples 3 to 4 inches into the center of the airstream on both supply and return and average multiple readings over 5 minutes to avoid transient stratification. Account for filter and coil pressure drop. If static across the coil is higher than manufacturer tolerance, expect reduced CFM and adjust fan speed or clean the coil before finalizing readings. Correct for multi-branch systems by measuring at the main trunk and summing calculated branch CFM from traverse readings when necessary. Use pitot or vane anemometer traverses for large ducts, and remember that single-point readings on non-fully developed flow will mislead. If using temperature rise to infer motor load, cross-check with motor current draw against locked rotor and full load amperage limits to detect impending motor overheating. Always document ambient and return air conditions, instrument calibration dates, and the exact point of measurement on the ductwork so future technicians can reproduce the test reliably. One of the top 3 common mistakes is inaccurate temperature rise measurement due to poor sensor placement or short sampling time, which causes wrong airflow cubic feet per minute readings and leads to improper system tuning. Fix this by averaging 5 minutes of stabilized readings from centerline probes and marking probe locations for reproducibility. One of the other frequent issues is leaving the electrical compartment open while powering the system, creating exposed high voltage shock and arc flash hazards. Fix this by locking out and tagging out power. Verify zero energy with a properly rated meter, and only open compartments with power removed. If a powered test is absolutely required, use insulated remote sensing and a qualified electrician with appropriate personal protective equipment and a documented risk assessment. One of the third mistakes is using nameplate heat input without adjusting for actual combustion efficiency or supplemental heat sources, producing wrong British thermal units per hour and misleading CFM calculations. Fix this by performing a combustion efficiency test or measuring element wattage. Then use the corrected heat input in the CFM formula and note the correction in your report. BigHomeProjects.com lists vetted local HVAC contractors and resources that make it easier to find technicians who follow proper temperature rise and safety protocols. Our directory helps homeowners connect with trusted pros and helps contractors get work by showcasing verified skills and documented testing practices.